और हमारे आज के गेस्ट स्पीकर हैं जनाब हक मिन्हाज साहब, and he is Director Eternal Energy. He is also a Director PE Consulting Group and ONG Trainer and Consultant. So prior to start the session, I will request the President Petroleum Club of Pakistan, Dr. Saeed Khan Jadoon, to please say a few words regarding the importance of to increase the productivity of oil production. Dr. Saeed.
जी बहुत शुक्रिया ताहिर, थैंक यू वेरी मच डॉक्टर गुलफराज साहब और हमारे मोस्ट सीनियर प्रोफेशनल फ्रॉम ह्यूस्टन से सजाद साहब और अकमनाज साहब, आप लोगों का बहुत शुक्रिया, पार्टिकुलरली अकमनाज साहब यू हैव put forward one of the most important topic, improving reserves and well productivity using new technology and process. ये all over the world usually primary and secondary जो रिकवरी होती है मैक्सिमम अप टू 30 या 40% तक जाती है, तो मोर देन 60% ऑल ओवर द वर्ल्ड जो है वो हमारे पेट्रोलियम रिजर्व जो है अंडरग्राउंड ही रहते हैं। और पाकिस्तान में अनफॉर्चुनेटली अभी तक कोई भी इस तरह EOR की टेक्नोलॉजी की एप्लीकेशन आज तक नहीं हो सकी, और हम कभी भी आज तक फ्रॉम 75 ईयर से वी कुड नॉट हैव एनी EOR एप्लीकेशन इन आवर फील्ड्स। वाटर फ्लडिंग हमने बहुत से फील्डों में की है, लेकिन अनफॉर्चुनेटली EOR प्रोसेस में स्टिल वी आर लैकिंग। और पार्टिकुलरली ये जो लेक्चर है और ये सेशन टेक्निकल सेशन है, दिस इज मोस्ट इंपॉर्टेंट विद रिस्पेक्ट टू द रिकवरी ऑफ द रिजर्व्स, इसलिए कि हमारे सारे फील्ड जितने भी ऑयल फील्ड्स हैं वो पोस्ट मैच्योर स्टेज पे पहुंच चुके हैं, और ये टेक्नोलॉजी और ये जो अप्रोच है ये मैच्योर एंड पोस्ट मैच्योर के लिए वन ऑफ द मोस्ट एप्लीकेबल है। आई होप कि अकमनाज साहब हैविंग ए लॉट ऑफ एक्सपीरियंस फ्रॉम शिला मर्जर और इस तरह इनकी E&P कंपनी में एक्सपीरियंस है, तो he will give us more insight about how we can increase, how we can improve the recovery of the existing from the existing field. So thank you very much, Akminaz sahab. Please go ahead with your lecture, and in the meantime, inshallah, we will be discussing more on the application of this EOR technology in Pakistan, what we can do with respect to the policy or with respect to the field development in different part of Pakistan. Thank you very much. Akminaz sahab, please go ahead.
Thank you, Dr. Saab. In fact, let me start with this Azadi Pakistan, 75th birthday of Pakistan. My grandson, in fact, yesterday he taught me how to sing Happy Birthday. So let's everybody say Happy Birthday to Pakistan.
Happy birthday to Pakistan. Very good.
Let's start with that, okay? It's great, in fact. Okay, these positive moments are really very kind of rare, and they give you a new kind of a sense of happiness in spite of all the problems and issues that we have. We still, this is our home, this is where we are going to live, this is where our generations are going to live. So let's try to do the best that we can for this country, for this nation. Okay, now coming back to the topic, improving reserves and productivity. When I joined, in fact, oil industry back in '82, and after initially spending a stretch of in petrophysics, I switched to reservoir engineering, and I was told that we produce only about 20 to 30% or 40%, and the remaining 60% is remains in the ground for oil. And since that day, I was really curious that why this thing is happening. This is, to me, that for a reservoir engineer, this is a sin. We are not doing a good job. And that curiosity basically kept on throughout my career, that why it is happening so. Dr. Jadoon Saab, you mentioned about EOR, and that is EOR is a buzzword. There was a lot of hype about EOR, enhanced oil recovery. And so much research has been done during last 5 decades on enhanced oil recovery. Yet, if we look today, the total contribution, global contribution of enhanced oil recovery is just about 4% in the overall production. So really, enhanced oil recovery has not delivered to its promise. Many companies have tried. I mean, even in that 4% that I mentioned, the majority is coming from thermal EOR, which is from Canada heavy oil, which will not produce otherwise at all. So if we remove the thermal component from enhanced oil recovery, rest is very minor. So I'll try to basically I'm not against enhanced oil recovery. I actually teach courses on enhanced oil recovery. And that's a wonderful thing, but we have to use enhanced oil recovery in its right place. So let's try to basically start this this journey and try to understand how can we improve our reserves. Okay, so to start with, I will use this picture or the image or that defines reserves and resources from SPE, Petroleum Resource Management System, PRMS, so-called. And when I looked at this picture initially, I was totally against it. I didn't like it. I actually even wrote to SPE committee that this picture doesn't give the true image of resources and reserves. And if you look closely at this picture, what it says is that, of course, all the reserves and the resources, they are recoverable, are potentially recoverable. Of course, you have here contingent resources, which is recoverable, but perhaps not commercial, or we do not have contract or something else. And then there are prospective resources. This is also recoverable. The problem is, if you look closely at this one, they have written here in very small letters, not to scale. If you look at this thing, the unrecoverable part is a small strip, but actually this unrecoverable is huge. So unrecoverable is kind of lost in this whole kind of misleading picture. Actually, unrecoverable is huge. And if you look at this picture, how can I hide this participant list? I don't think I can do that, right?
Just click on the participants. It will go.
Let's see if I can. Participants. No. No, I cannot. Anyway, what is happening is, in fact, part of my screen is kind of covered by participants. But that's okay. Can you see the whole screen?
GD.
All right. Okay. All right. Okay. So let me see if I can somehow. Oh, I can hide now. Fantastic. All right. Thank you, Taisa. So I will put this this image in a slightly different manner. That we have original oil in place, which is our volumetric estimate. Could be volumetric estimate or computed from different ways. And then out of that, this is our reserves that we can commercially produce, which is actually initially it is estimated EOR, so-called estimated ultimate recovery, and what is remaining today is reserves. And then we cannot change our original oil in place, but how can we improve our reserves, which is in fact a multiplication of original oil in place multiplied by recovery factor. In other words, how can we increase our recovery factor to increase our reserves without doing any new exploration? So that's really, in fact, the importance is coming these days, because the new resources exploration opportunities are becoming less and less. So if we can add reserves in the existing fields, existing discovered hydrocarbon, that would be a wonderful thing. So how can we do that? So that is the subject of this this topic, how we can make this yellow part much bigger than what it is today. A better picture is shown by one of my favorite books, Mike Shepard. I don't know if you have read that book, but he has giving in fact one example of one field, and he has split the total in place volume into different things. He calls this the maturity pie chart, where this whole image, whole pie, whole circle is basically oil in place, and within that there is some part has been already produced, which is cumulative production till to date, and there is some part which is still remaining, which is actually reserves. Okay, so remaining and reserves is actually the same thing. But then this field was probably under water flood, and when water flooding was done or water injection was done, then water swept a lot of oil and some oil was left behind, and that is residual oil. Okay, so this residual oil is there, and this is the target for enhanced oil recovery. But there is a lot more than that, which is unrecovered mobile oil. It is mobile oil, it can flow, but it is unrecovered. In many reservoirs, many cases, it is in reservoir heterogeneities, in compartments, in because we don't have any well in that area due to different reasons, mostly because of geological complexities that remain. This oil remains unrecovered. So there are two elements over here. One is that the oil which is there that we can access, we can in fact increase that production through water flooding, water injection. Yet within that flooded or the swept zone of water flooding, there will be a lot of oil that will remain there. In some cases, it is 10%, some cases it is 15%, 20%. This is the target for enhanced oil recovery. But there is a lot more in this pie, this little part, which is almost half of the total pie. And there are many fields studied, and this is really the area where we have that hidden oil. Because if we want to increase the reserve, first thing is we have to understand where is that hidden oil that can be easily accessed. On top of that, this part of the pie, which is hidden oil or unrecovered mobile oil, all it needs is to drill certain wells in a different manner, probably horizontal well. What we call in Saudi Aramco is maximum reservoir contact wells. And produce that oil. Whereas this part, which is the target of enhanced oil recovery, needs much more difficult processes, which includes injecting sometimes chemicals, injecting CO2, doing some lab studies and pilot studies, and there are many enhanced oil recovery projects which started and could never mature itself, okay, because of these complexities. So, but anyway, we'll talk more about that. So recovery factor is, now we know that is estimated ultimate recovery divided by initial oil in place. And this, in this case, this estimated ultimate recovery is this one. Sometimes we use the term loosely as reserve, but really what we should be talking about is estimated ultimate recovery, which includes the reserves today, that is remaining reserves, plus what has been produced so far. So that is the, if we take that figure, whenever we are talking about recovery factors, this is the number that we have to consider. So what has been produced, that is actually part of what has been recovered. So now, there are two ways to increase our recovery, or typically that's used. One is that if, for example, let's go back in a minute. I'll try to basically put very few slides, and there is a lot more details that's not really shown here. There is primary recovery, that we, without any water flooding, we just go and poke a well and we start producing it, and the oil itself slightly expands, and eventually it goes through different things, like there is gas which is present in oil, and there's a lot of gas. There is probably in each barrel you may have few hundred standard cubic feet of gas. So that's a lot of gas present in each barrel of oil. So if when we produce the oil, the pressure goes down, and when we go below so-called bubble point pressure, that gas in the oil starts coming out, and that gives a lot of push to the oil and somehow maintains that energy. But it is not a very efficient way of producing, because gas is has very low viscosity, probably sometimes less than 50 times of oil. So it can move very freely, very easily, and it will bypass the oil. Rather than pushing the oil, it will bypass the oil. So it cannot really do push it. It can slightly maintain that pressure, but not really push the oil. It is the least efficient way of recovery. If we have a very strong aquifer, or a huge source of water, and typically if it is thousands of times bigger volume than oil itself, then it can give you, and it is very well connected with your oil reservoir, that can give a lot of push to oil. That's wonderful. But it's very few cases that we have such a huge and big aquifer. So in most of the cases, we need water injection. In almost every field that is I have seen, except some few fields, few in US, you need water injection. So when we do water injection, this is basically what water injection does is it pushes the oil. So it is, number one is it is doing displacement, and secondly that water injection provides pressure in the reservoir. So it is used in two manners, maintaining reservoir pressure and secondly displacing the oil. And both these factors, they contribute, and we can produce oil. Oil recovery becomes very good. But then there are other, it's not just in fact putting a water injector and producing that. We have to understand many different things, that their reservoir itself is heterogeneous, and the way water is going to sweep that oil, it will sweep high permeability quicker, and we can have some water breakthrough. So we really have to be careful, understand the reservoir, and inject the right amount of water in different parts of the reservoir so that our sweep is kind of like a piston, all right? And it is, we don't make a water breakthrough. So if we put all these things together, we should be able to achieve good recovery. Of course, still, as we mentioned, that in this area of water swept, some oil will be stuck in that pores, okay? And that will remain there within the pore, which is the target of enhanced oil recovery. So one thing that we do to increase our recovery is push the oil. The other thing that we do is reach the oil. Okay, sometimes the oil is in a difficult geological part where our, for example, this vertical well will not be able to produce this attic oil that is sitting up there. We have to now reach the oil using complex wells. Sometimes we drill very complex wells, and these days the technology of horizontal drilling and lateral drilling has advanced so much that this reach the oil has basically overtaken the industry. And this is something that we are not really using. Of course, this alone is not enough. This reach the oil has to go together with push the oil. So when we combine these two elements, that is where we can get highest recovery, and this is where we can make this part of the pie less and less. Okay, and we can keep on increasing our recoverable, our reserves. Okay, so that is essential. We have to master both these technologies: push the oil and reach the oil using complex wells. This hydraulic fracturing is also a way of reaching the oil. What we do in hydraulic fracturing is we make our well go behind its normal radius and reach the oil, reach the reservoir. Okay, so of course it gives the oil an easier path to flow but we are also reaching the oil. For example, in this case, what is happening is that close to wellbore, there is an area of damage. All right, so that will not allow all the oil to move from here into the wellbore. But if we make a hydraulic fracturing that bypasses this damage zone, we can reach that oil which otherwise were hidden behind this low permeability region. All right. Sometimes it is a very small hydraulic fracture just to bypass that skin area or the damage area. Sometimes that hydraulic fracture in low permeability reservoirs can be very, very large, many hundreds of meters. So in that case, we are basically allowing all the oil sitting in the low permeability area to enter into this fracture, and from this fracture, which gives in fact a kind of a corridor of high permeability, it flows into the wellbore. Okay, so hydraulic fracturing is another technology that can help produce improve the well productivity and ease the flow of oil both in high permeability and in low permeability. That is another technology that we need to master here in Pakistan. Okay, now coming back to this reserve thing, that I just put here a number. What is the catch? What is in it for us? And to make ourselves realize, of course, people sitting in this group are basically experts, spend all their lives in this business. It is basically kind of insult showing these figures, but if we talk to anybody in government department, these are the kind of numbers that can help as an eye opener for them. That if, for example, we start with an oil in place typical for a country, I didn't really take the example of Pakistan, but it could be close that if our oil in place, original oil in place can be about 2 billion barrels. And if we are using a recovery factor of 20%, our estimated ultimate recovery is about 400 million barrels. If we can jump that recovery factor to 30%, we have an additional 200 million barrel of oil. So that is how much additional recovery factor can make a difference. So if we have, in fact, if we get a field of even 10 million barrel, we start jumping upside down. But with this thing, I was in fact once wondering that why is it that reservoir engineers, by doing a better job, they can actually add millions of barrels in the reservoirs, and there is not much excitement about that. And I realized that it is actually the job of exploration is very much exciting. If we discover a well, it becomes a highlight. In fact, it comes on television that, well, we have made a discovery of 2 million barrels. But if there is a company, they are quietly doing a good job, their recovery factors are good, they are adding millions of barrels of oil, that goes unnoticed. This to me is not fair. Anyway, so this is we can add a lot of value to our existing fields by increasing our recovery factor. So that really is the area that I believe in Pakistan we should focus, and we should focus as a task force, or with whatever weapons we have, and that is really an area which is being ignored. There is a lot of focus on exploration, and this is an area that we should look at. Now, if recovery factor and reservoir management is so important, then we can add millions of barrels. Then what is it that? Why is it then in some fields recovery factor goes from 10% to 70%? In some fields it can be as low as 10%. In other fields it's 70%. And this is something that I was, in fact, throughout the time that I was working in different fields, from Petroleum to with Baker Hughes, with many different companies, with Schlumberger, many different customers, and looked at hundreds of fields. And always there was a question in my mind that what really controls recovery factor? Okay, what is so special about the fields that achieve 70% recovery factor? And of course, the next question is it the impact of geology alone? Of course, geology is important. Okay, for example, a field is very homogeneous, you would expect a good recovery. A field with good permeability, you would expect a good recovery factor. But is that the only thing? We reservoir engineers, we are engineers. Our job is to engineer the reservoir. Okay, so how much engineering can we do to increase that recovery factor? That is what is the kind of contribution of geology versus engineering to improve that recovery factor? And then, as I discussed earlier, is EOR is the only tool to get high recovery factor? All right, so I'll try to basically put all these things in one picture that I hope will help us understand. Now, what I learned is that really, and which is quite often ignored, is the reservoir understanding is the starting point. If we don't understand the reservoir, if we don't characterize the reservoir fully and properly, and we start producing that field, we have a discovery well, we start producing it, and then to increase production, we put another offset well, another offset well, another offset well. That's okay. We can produce that. We can get our investment very quickly out. It's good for many operating companies, but is that the best way? I believe not. We have to understand the field in terms of its heterogeneities in large scale over many meters and kilometers to small pore scale level. If, for example, we realize that in pore scale there are reservoir heterogeneities, in many fields, what people have started doing is that an on-site recovery has taken a different shape, that from day one, they are injecting chemicals in that water that improve that recovery. For example, this low salinity water that's being used in many reservoirs, sandstone, even to carbonates in Saudi Aramco, for example, to polymers which are being used in many fields in China. So they start injecting water, and right in beginning, they add some polymers in that water. So that makes the water more viscous, and it can now do, in fact, a sort of sweep, piston-like sweep. Okay, so especially when the reservoir is very heterogeneous, you need that water being much more viscous compared to oil to push that that oil properly. So that is EOR is now becoming, rather than EOR was initially as an add-on, that you think about EOR once the field is depleted, once there is nothing else, the field has declined. But now, in fact, EOR is taking a different shape, that many companies are thinking about EOR upfront at the time of field development. All right. So if we do it right, hopefully we will be able to increase this pie of recovery. Let's go back and think about what are the processes that can maximize my recovery. All right, there's a lot more that goes behind that figure, but I'm just putting here the whole thing in one. All right, it is like a pyramid, and in that pyramid, the first thing is the initial development. When we understand, we of course, behind that is also we characterize the reservoir. If we understand the reservoir, we characterize the reservoir, and towards the end, I'll show you many different courses that I teach. One of my courses is actually reservoir characterization to enable high recovery development. All right, so we need to understand, characterize the reservoir, understand the reservoir properly, so that we can develop in a manner to avoid any kind of hidden oil and any escape of oil or unproductive oil. Okay, so the first thing is understanding the reservoir. Once we understand the reservoir, then with that good understanding, good model, we put up a development plan. We call it field development plan. And that field development plan is not just a kind of conceptual plan, but before that, we collect enough information at early stage. And believe me, that information is vital. The early time, initially after exploration well, the appraisal well that we drill, the course that we take, the quite often 3D seismic, which is so essential that we do, that is so important to put our development plan properly. That if we need water injection, what kind of water injection scheme do we need? Do we have strong or a weak aquifer? Do we have any possibility of gas cap? Is there vertical permeability is good enough that I can create a gas cap, a secondary gas cap, or if there is a primary gas cap, can I announce that if the vertical permeability allows that? All right. So what is the natural forces which are present that can help me maximizing recovery? If not, then I need to do some water injection plans right from beginning. Okay, because if water injection is delayed, it is not as beneficial, as we all know that very well. We put up an initial development plan. This is actually this process that I'm showing. We had adopted that process more or less from in Petronas from Shell. So I went through this entire setting up this complete cycle of reservoir development. All right. So I must admit that many of these concepts were borrowed from many other companies, including Shell. Shell happened to be our partner with Petronas, where I was working there. So initial development plan that we put up there, and the well thought plan that it is, the more well thought plan and thorough this plan is, the better it is. Okay, we start on the right footing. Not only that, once we start producing some wells, we may realize, we may feel that things are not going as planned. Wells and the field is not behaving as we had anticipated. So after all the wells have been drilled, quite often we have to make a revision to that field development plan. All right. So our predictions could be wrong. So and everything, including RFTs or NDT pressure in offset wells after production of initial wells, to some kind, we do some well to wells pressure pulsing testing or some tracer testing. So all those things are done basically to understand the reservoir continuity and to investigate if there is any possibility of having different compartments within the reservoir, where I may leave some unswept oil. Okay. So when all these things are done, and then here in this little flags, I am using these terms ED, ES, and EPS. What this thing is, let me go back to this equation, which is recovery factor is a product of three different efficiencies. When we are assuming that we are doing water flooding, there are some areas of the reservoir that will be disconnected, like compartments. All right. So if we don't reach every compartment, this our ED will go down less than 1. If assuming that if I have reached every part of the reservoir, ED can be as much as 1. Okay. Then I should have a perfect sweep control. So that means that I have swept every part of the reservoir. That is how that is controlled. That is controlled through well placement. That's controlled. These days we have, we used to have chokes at surface, but these days it's very common to have those chokes downhole using so-called inflow control devices. And what they do is with those inflow control devices, I can control that how much water I want to inject or how much oil I want to produce from different zones. So I divide my well into different segments, and I can control how much. They're also called equalizing devices, and the purpose is to equalize production and injection into different part of the well. That becomes so important, especially in long horizontal wells. So if I can do these two things, if I can avoid any oil being lost in compartments, if I can achieve a good sweep, and the last thing is if I have left any oil in the pore scale level, which is those zones which have been swept by water, if any oil is sitting there, that now I have to go down and with the enhanced oil recovery techniques and inject some kind of maybe surfactants or miscible gas that can unlock that oil which is hidden in little pores. Okay, so that is actually the apex of this whole triangle. Once we have done everything right, then at that time we are going to address this issue of pore scale displacement using enhanced oil recovery. All right. So what here I'm putting here is FDP, not only making that FDP, but then of course there is a lot of efforts that goes into FDP execution, and that it is executed properly the way it is done, and then revise FDP later on to basically accommodate any information and include any information which is coming from new wells and new production data and all that. That will show, in fact, could show a lot of surprises sometimes. Okay. Is everything okay? Everybody can hear me okay?
ठीक है, it's okay.
All right, great. Any questions so far?
मैं ख्याल में
should we leave it to the end, huh?
जी एंड पे छोड़े, क्योंकि इस तरह डिस्कशन शुरू हो जाएगी तो फिर मुश्किल हो जाएगा. जब आप खत्म करेंगे तो we will have a question answer session.
Fantastic. Good. Sounds good, Doctor. All right. So then, of course, needless to say, reservoir monitoring is so important. Okay. So reservoir monitoring could be in many different parts. It is like doing pressure measurement, doing pressure build-up test. If we drill a new well, we should acquire pressure data in the through RFT or MDT or RCI from different companies. Which is so essential, so important, getting that pressure data from each zone. Those data can identify any presence of compartments or bypassed oil. That is really so important. Okay, so then we say that EOR is to maximize the getting the last drop of oil. That's where the EOR comes. Okay. Now, let me go back to FDP process. In all this thing, all this picture, everything that I've seen so far, I have gone through a lot of SPE literature. The most important thing is putting the right field development plan on day one. Of course, before that, doing the reservoir characterization properly. Okay, so and quite often, in fact, in the management, there is an issue of getting that information, because many people, companies, they consider that spending money on collecting data or information as a cost. And in industry, there is no, it's quite common to talk about value of information. That if we can identify a compartment in a reservoir, and it can basically mean, in fact, many thousands of barrels or millions of barrels of additional oil that could be hidden there. All right. So then, when we put that perspective, that if we get that information, it will have so much value, then that cost becomes an investment. It is now no more a cost. Okay. So the cost for cost controller is a cost, but for reservoir engineers, that is an investment. Okay. So the way we do this field development planning process is that we appraise initially, we collect information, and we consider, with that information available on day one, we can have many different alternatives to develop that field. Or it could be, for example, if in an offshore, we can use a subsea kind of development, or we can use a dry tree. In offshore, in onshore, there could be many different well mechanism, having multiple vertical wells, or maybe drilling from one platform, drilling horizontal wells and reaching every part of the reservoir. There could be many different concept developments. So, but at that time, we have enough information that we can, without building any simulation models at this stage, we can, at very high level, we can look at different development options, and sometimes it is very easy to select one best option. Sometimes we are left with 2 or 3 possible options that we can carry into next phase. So after appraisal, getting all the information, we do, in fact, I'm talking here about the field development plan, which is now is becoming an industry standard. I really don't know. I didn't work for too long in oil development in Pakistan. So Dr. Said Yadoon, I will request you at the end to tell us how close we are to this standard. Okay, then we select the best option for development. And next thing is, by the way, down there, I have little telescope that, which is very important. It's very important. In fact, many companies are using different focus. At early appraisal stage, our focus is, in fact, information gathering. At that time, and any well that we drill, we have to get as much information as possible, including pressures, logs, cores, whatever. At that time, the cost should be, we should not really allow our cost controller to talk too much. Okay, the reservoir engineer should be in the driving seat. We have to collect as much information as possible. And quite often, this is a mistake that happens. At that time, we start talking about cost cutting. And if we do that, we will not have enough information to go to the next phase. Okay. Then when we go into the select phase, that we have selected the best option, then we take that option into development. And select, of course, is a very rigorous process. And I'll show you another aspect over here, which has become almost a standard in many companies. And that basically adds a lot of new value in the entire value chain. Okay. Then we take the selected option and we make now, in fact, detailed development plan, including simulation model, and we come up with production profile that, well, if we do this kind of development from so many wells, and its production will look like this, and that is how much oil we can produce. This will be our recovery factor, expected recovery factor, and this will be our production profile. And then we can, of course, talk about the economics of that field. We know that how much production we will have, how much revenue we can have, how much cost of development will be there. And then we can take that thing to the management and get the approval. Okay. And once that approval is taken, then we go into execute phase and start developing that field. All right. And of course, then we go into operate phase. But here down there in these little white blocks, you have FDP1, FDP2, FDPX, so on. What it really means is that at the end of this defined phase, we have now FDP1, Field Development Plan 1. We go with that, we execute, and when we execute, that means basically drilling many wells. Once we drill many wells, we will understand a lot more about the reservoir. We start producing some of those wells, we'll understand more. By that time, we have a lot more information available now, and that will be an opportunity to go to revise that FDP, field development plan, that we have put together initially, and make any adjustment based on the new information that we have collected during this time. This is so important, okay? So down there, here, our focus changes, in fact, from information gathering to optimizing. Then when we go to this defined phase, by this time, we know we have to develop so many wells. We try to go into optimization. And once we go into this execute and operate phase, this is the time to talk about cost reduction. Because one thing is that we'll be drilling many wells. And now, in fact, if we talk about cost reduction, that is the right approach to do cost reduction, because now we are we understand it very well. We have development plan in our hands. Now we can think about different terms. If I drill these wells this way versus this way, which is the best possible option. Okay, so we use really a kind of proactive approach here. Let me go back to 1 second here. Another thing that is done, which is not shown over here, is that we have decision gates, and all these processes are reviewed by experts. Usually, in many companies, there is an external review team. What their job is, they come and review at the end of a praise phase that, okay, well, we have collected enough information about this field that we can go to the next phase of select gates. People, Shell calls it, in fact, decision gates. So we go through different decision gates. So this part is basically reviewed by a team of experts. We call it also project assurance review, that is done periodically at the different phases of the project. Once we have selected that one phase, it is not just the project team that selects one phase, but then once they have selected that phase, they have to defend that in front of that review team. And once we introduced this idea of project assurance review in Petronas, again borrowed from Shell, we really saw tremendous value coming from this simple project assurance review. What it did was, number one, is that team of experienced people, they could inject their ideas and their knowledge into field development. Just one team was able to basically review maybe 3 different projects in a month. So imagine, in fact, now you are sharing that knowledge across the entire domain. And probably similar thing can be done here in Pakistan at the country level. We basically have a review team of experts, maybe at the regulator level, that can review every project and make sure that the things are done at par with the industry standard and properly, and there is no gaps in that development or in that work that has been done. Then and there was another benefit of that, and that benefit was then when that experienced team used to sit with that project team, and it was not really a kind of examination, but they used to work with them as a consultant, as a mentor. And that was such a big booster to the knowledge of that young team that is unbelievable. In fact, all our training programs, we realized that in many of those cases, the amount of training imparted to that young team or the project team is much more through this process than by any other school or classroom training. So this was really a kind of on-the-job training. But then it has to be managed properly, that it doesn't become an examination. It was not really stressful for the project team. It was done in a friendly manner, in a mentee and mentor kind of relationship, and it has multiple benefits. I can keep on talking about it for hours and hours, man. Okay, now the other thing is that we go through a project life cycle. It is not really one time. That is, again, I'm repeating myself to some extent. We basically appraise, we formulate a field development plan, we execute development plan, we do reservoir surveillance or basically monitoring. We compare the data, that the production data or pressure data that we acquired with our predictions, so-called the history matching, and try and make sure that our reservoir is behaving as we were expecting it to behave. If there are any kind of, if the reservoir behavior departs from the expectations, that means we have to readjust. That means our reservoir understanding was not correct. So history matching is here used in a way to understand reservoir more. So history matching, many people consider history matching as a quality control, but to me, history matching is really a reservoir characterization tool, because history matching allows us to ensure that we are not missing anything in the reservoir. We understand the reservoir properly, right? So this is the kind of cycle that we go through. Now, in that thing, there are many technologies which have been helping industry. Okay, to me, in fact, it is the processes than the technologies. But there are technologies that recently have been helping a lot. Initially, when we are doing, for example, water injection, and our horizontal wells, in fact, many horizontal wells initially, when they were drilled from in Norway, they realized that the wells, okay, initial production from the horizontal was fantastic, but soon the well will start watering out. And when they run different production logs in those wells, they realize that many times the heel of the well is actually what is making water. And then they studied, in fact, in depth this issue, and realized that at the heel of the well, there are so many pressure drops that the water will be pulled up at this point. Sometimes there are also some permeability heterogeneities that will pull up this water. Am I going too fast, Taisa?
It's okay, जी.
Okay. Sometime, while
मतलब ये है कि अभी आपका तो 45 minutes हो चुके हैं, तो I hope कि 10 minutes more is enough for you या ज़्यादा है?
Well, I can wrap up in 10 minutes. I always, my speed becomes so fast that I always have to tell myself, slow down. All right.
Let 10 minutes और ले लें और फिर उसके बाद question answer session का फिर चीजें explain कर देंगे.
चले, ठीक हो गया. So the other thing, of course, I'm going to skip some of the technologies, but some of the key technologies which are there actually, this is for production, reservoir production, we want to basically equalize that production. I talked about inflow control devices. This is such a fantastic thing for reservoir management and recovery, because imagine if in this case, if this heel of the well is watered out, we will just start producing water, and there is tons of oil sitting here that will remain there, forever. But what we do, what this ICD does is, as I said before, ICD or inflow control devices are like downhole chokes. We choke these different parts of the well in such a way that we equalize the production from each part of the well equally, and this takes care of any kind of differences in the well bore pressure from heel to toe. At the same time, it takes care of any heterogeneities. For example, we might have this area which is more permeable, this area which is less permeable. It will take care of that. So end result is that the water upward movement of water will be gradual. All right. So this was such a fantastic technology. It is being used in almost every horizontal well in many companies. The other is, of course, horizontal drilling. This technology has overtaken anything. Horizontal drilling with geosteering. Probably these things need really a complete separate session. Of course, towards the end, I'll suggest you some of my courses where I cover these things in full details. So horizontal drilling and the technology of geosteering and the accuracy that we have achieved together with the new measurements that can basically detect any presence of water or heterogeneities in the vicinity of hundreds of meters above and below, okay, and make sure that we remain in the reservoir and stay in the optimal path using geosteering. These are two fantastic technologies. Now, let me, we do all these things, and of course, considering short kind of time is a bit short, let me go back to this thing that, let's say we have done everything possible. We want to now measure ourselves how well we have done in terms of recovery factors. Benchmarking has been a great tool these days. Okay, and this, in fact, I'll spend a couple of minutes here, and this can be very much applicable to here in Pakistan. The problem is that when we talk about recovery factors, many people say, well, okay, our reservoirs are very complex. It is low permeability. That's why it's not really producing. But that is not really a kind of very objective statement, and not something that's coming from a reservoir engineer. It can be from any layman. Anybody can say, well, our wells are too complex. We cannot really achieve high recovery factors. And a similar thing was happening from UK. These are all the fields from UK continental shelf, and there is the regulator there is Oil and Gas Authority in UK. This slide was made by them, okay, by a third party. In fact, they are kind of my friends, and we can do some similar work over here. What it does is that this NRC, what they did was they plotted all the fields in this plot, where on the x-axis, we call it field quality index. This field quality index is what? It is basically a combination of many things. It is the combination of how homogeneous the reservoir is, what is its permeability, what is the mobility of the oil, how many compartmentalization or heterogeneities are there in the reservoir. It is a basically complex relationship. And in our case, for example, it could be as simple as reservoir permeability. In that case, if we plot a recovery factor in different fields versus field quality index, and this is a fantastic plot. If we forget about anything in the presentation, if we can use this thing here in Pakistan, this is so nice tool that immediately I can identify underperforming fields. I can identify underperforming wells. If we plot this field quality index versus recovery factor, I can see here that when the field quality index, which is basically a kind of geological aspect, okay, is low. In fact, their field quality index was very complex. It could be a very tight reservoir. Of course, recovery factor is low. For very good field quality, recovery factor is very good, which is understandable. But if you look at different fields, what we see is that for a similar field quality index, there are some fields which are not doing well. There are other fields which are doing so well. Okay, so look at this variation for a given field quality index in terms of recovery factor. When we talk about this kind of quantitative plot, our questions of geological differences are, of course, they go away immediately, because now we are talking, we are comparing apple versus apple. Okay, so we can then, in fact, in this example, in that case study, they went to the next step. In fact, in two stages. Stage one was that what wrong was done in these fields or reservoirs that made them produce less or recover less. All right. So then they basically examined this thing in great detail. Water injection was not correct. Well placement was not correct. What was wrong in this case? At the same time, so the first thing is to push all these fields from here to the normal number. And second step was to understand the best practices that this guy over here has done or this guy over here has done, and copy those best practices to overall fields and try to push this curve from here to here. And you can imagine, in fact, if we do this exercise for a country at the regulator level, the gain overall will be tremendous. Okay, so that could be an approach to basically check ourselves. And not only within Pakistan, we can have analogs from outside Pakistan and bring those analogs over here and compare and plot a field quality index, which is collective of our reservoir versus the reservoirs from another similar area, and measure ourselves versus others. Okay, I may skip this one, but let me just, it is applicable to our fields anyway.
इस पे अगर आप कुछ अगर एक दो स्लाइड या दूसरा इंट्रोडक्टरी तौर पे बता दें ताकि लोगों को अंडरस्टैंडिंग डेवलप हो जाए.
Okay, I'll try to just go quickly. We know that we have huge resource of shale oil and shale gas, and this is just one plot that shows that shale oil, how much it has done. It has basically totally changed the picture of US. This is US production. it went up from 6 million to 9 million and 13 million and 14 million. So you can imagine what it has done in US. But can we repeat that thing over here? Well, it will be kind of difficult. And this was the kind of question that I was posed with when I was working with Baker Hughes and for Saudi Aramco, when Saudi Aramco started looking at Jafurah Basin, which is a shale gas play. And they asked us, in fact, how can we do this thing like this? We don't have time to go spend 20 minutes to learn all these things. How can we do this thing in 2 or 3 years? And we started looking at that. In fact, I put one SP paper also based on that learning. We surveyed and we read, I don't know, in fact, how many hundreds of SP papers, okay, and interviewing many different people. So, and the key point here I want to make here is that there is so much learning that has happened in shale gas development that if we do anything today, starting not from zero, but starting from what had been already understood from shale gas development, we can reduce our learning curve, we can reduce our cost, we can basically quickly go on this journey of unconventional. Okay, so I'll skip this thing. What really hydraulic fracturing does is, I'll mention this slide, and it is in fact applicable in many areas in Pakistan, even without shale gas. In tight reservoir, tight oil, we talk about tight gas, we don't talk about tight oil. I don't know why. Now, what hydraulic fracturing really does is that here in this plot, and it's a magic one, it's a really magic thing. What it does really is that if we have any fractures, natural fractures, or artificially we create fractures in the rocks, which is otherwise that could be tight, then after creating those fractures, what is the effective permeability of that rock, having those fractures and without those fractures? And this I have plotted versus different rock permeability. So here there are two different things here. This is the matrix permeability, 0.1 microdarcy, 1 microdarcy, and this is 0.1 millidarcy. This is a high permeability rock. So what we see is that if I have a very tight rock and I put fractures in that rock, my effective permeability can become thousands of times more. And this is not really restricted to only shale gas. It is also applicable to our tight oil. And now we have basically, if I relate this thing to our fracture carbonate reservoirs, what we do these days is that, I mean, always in many years that I've spent in Pakistan, we drill a well. If we find fractures, we produce that and we say that, okay, well, I have a successful well. If we don't encounter fractures, it is just a matrix. Of course, the well will not produce well, not produce at economic rate. And we said this well is really a failure. Why is that? Why can't we use this technology and put fractures there and develop that area also that does not have natural fractures? So this is my just a key message from here. And the understanding from US is so much. Let me give you one image here. They spend millions of dollars trying to understand how the fractures works, what fractures look like. There was a series of SPE papers that were written. What they did was they drilled many horizontal wells, fracked those wells. Then they drilled, in fact, a vertical well that was passing close to those fractured wells. And they took course along this well, and they tried to understand. And from that course, they tried to see, of course, these fractures were also propped. Sand was injected in those fractures. So imagine, look at this sand. This is the sand, the way it looks like inside the fractures. And this is how those fractures look like when compared to these natural fractures and the artificial fractures. So there is a lot of understanding of this thing, not only from based on model, but actually going down and trying to see that how those fractures really look like. And the result of all this thing is that people were in 2010, they were over here. The wells were producing, this is the well profile in 2010. In 2015, I don't have this figure after 2015. In 2015, the wells that were drilled over here, the production profile of those wells is over here. So the wells, the technology has been perfected so well, and there have been so much improvements in the technology through many different things, not just increasing number of stages, but many other things. The way we do the hydraulic fracturing, we can actually produce much more from those wells compared to what people used to do in 2010. So we are in a better shape today to take that all that learning and apply to our tight oil, tight gas, and shale gas. And hopefully we can get to this level. Now, I'm sure you won't laugh. This is a little commercial for myself to back up this, what I said just now. These are the courses that I have been teaching in the industry. Reservoir characterization for recovery improvement, stimulation, which is a quick approach to increase well production, stimulation both in the sense of matrix stimulation and fracture stimulation. Geomechanics, which is kind of ignored. It's so important both in drilling and hydraulic fracturing. I do one course on that. Reservoir fluid characterization, understanding the fluids, not only oil wells, but also in gas. Quite often we have gas condensate, and we know that in gas condensate, we produce some gas and we leave tons of liquid in the reservoir, and we damage all the reservoir. How can we avoid that? And there's much more into that. Developing shale and tight reservoirs, reserves and resources. I did many of these courses. There were many issues. In fact, there are differences in the reporting standards of SEC in US versus PRMS. What are the differences? The deterministic versus probabilistic methods. So I'm available to teach all these courses with the in the right environment. And I believe that really, in fact, what I do is after every prayer, I have this, my favorite dua is Rabbi Zidni Ilma. So, and this is really what we lack, in fact, in our community in Pakistan, is that the motivation to learn more, to add knowledge to ourselves is not there. It's pity that the day we leave our university, we close our books. That's the end of the learning. That really should be the start of learning. Thank you very much.
Thank you very much, Agnasa. It's a really great, wonderful lecture, and a lot of things new comes to our mind. I hope people will be getting a lot of benefit from your discussion. और बहुत सी ऐसी चीजें हैं जो पाकिस्तान में डेफिनेटली एप्लीकेबल है एंड एप्लीकेबल हो सकती है. अनफॉर्चुनेटली चले वक्त के साथ हो सकता है कुछ मुख्तलिफ कंपनीज में काम हो रहे हैं. हाउएवर जो बस सिर्फ मैं 1 मिनट लेते उसके बाद क्वेश्चन आंसर का सेशन करते हैं, और जो भी क्वेश्चन करना चाहते हैं प्लीज रेज योर हैंड सो दैट वी कैन रिकॉग्नाइज हु लाइक्स टू स्पीक, और टू दी वेरी ब्रीफ और ब्रीफ क्वेश्चन या कमेंट्स हो, लेकिन ब्रीफ प्लीज, क्योंकि टाइम काफी हो गया है. 12 डेवलपमेंट प्लान जिस तरह आपने अर्ज किया, जो प्लान इसी तरह तकरीबन पाकिस्तान में जितने फील्ड डेवलप हुए हैं, आजकल अच्छी बात हो गई है कि डेवलपमेंट प्लान से पहले अर्ली प्रोडक्शन फैसिलिटी भी आ गई है, जिनकी बेसिस पे डेटा कलेक्ट किया जाता है. और एग्जैक्टली ये साइकिल टू सम एक्सटेंट इस तरह फॉलो होता है. पाकिस्तान में कादरपुर, ओच फील्ड, टल ब्लॉक डेवलपमेंट, माड़ी की फील्ड जो डेवलपमेंट हो रहे हैं, पुराने फील्डों के अलावा जो जितने भी पिछले 20 सालों में फील्ड डेवलप हुए हैं, काफी सारा फील्ड डेवलपमेंट स्टडीज होती है बाकायदा. उसी तरीके से अर्ली प्रोडक्शन फैसिलिटी, एक्सटेंडेड वेल टेस्टिंग होते हैं, उनसे डेटा कलेक्ट करके फिर डेवलपमेंट अप्रेजल जो रियल प्रोसेस है उसी को फॉलो किया जाता है. सम टाइम डिले होती हैं चीजें, लेकिन इस तरह गवर्नमेंट ऑफ पाकिस्तान उनको रिव्यू करती है और फिर थर्ड पार्टी सर्टिफिकेशन के बाद जो है वो डेवलपमेंट प्लान अप्रूव वगैरह होती है. तो प्रोसेस चलते हैं, तो सम एक्सटेंट कहीं ना कहीं डिले होती है, लेकिन जो आपने कहा है कि इसी तरह ही फॉलो किया जाता है. बहरहाल सिर्फ जरूरत इस बात की है पार्टिकुलरली कि डेवलपमेंट प्लान जब बन जाए तो उसकी एग्जीक्यूशन हमारा फुकदान होता है कि कमर्शलाइजेशन फील्ड को करना जो है ना, ये बहुत थोड़ा उसमें डिले होता है कि डेवलपमेंट प्लान की अप्रूवल, और ये थोड़ा सा प्रोसेस को फैसिलिटेशन की जरूरत है. अदरवाइज चीजें टू सम एक्सटेंट इसी तरह ही चल रही होती है, लेकिन इनमें एफिशिएंसी लाने की जरूरत है. तो मैं और बात ज्यादा नहीं करना चाहता. ड्यूरिंग डिस्कशन वी विल टॉक, तो लेट्स गो फॉर क्वेश्चन आंसर सेशन.
I agree. In fact, let me, Dr. Sir, let me just make one little comment here that this process is more or less done in many cases. But what I realize is that if we add that element of assurance review in that process by an independent authority, not in-house assurance review, because in-house assurance review is really not like we have the same knowledge that is circulating. So if we have, if we include that external assurance review, that you believe me, that will add a lot of value.
जी बेसिकली फील्ड डेवलपमेंट स्टडी इंटरनेशनल कंसल्टेंट ही करते हैं, तो फिर जो जॉइंट वेंचर पार्टनर तो सारे रिव्यू करते हैं मुख्तलिफ जॉइंट वेंचर फील्ड के. एनीवे दिस कुड बी डन, अगर कोई कंपनी करना चाहे दे कैन बट ये फील्ड डेवलपमेंट बाकायदा इंटरनेशनल कंसल्टेंट की स्टडीज होती है तकरीबन सारे फील्ड, तो वो फिर अपने लोगों की उसमें इनपुट भी होती है और लोग पार्टिसिपेट भी करते हैं जॉइंट वेंचर की मीटिंग्स में, टीसीएम, ओसीएम. फिर जैसे आप भी इन्वॉल्व रहे हैं फील्ड कंदनवारी फील्ड डेवलपमेंट में, खुद इसमें इन्वॉल्व रहा हूँ, टल फील्ड डेवलपमेंट हुआ, तो ये प्रोसेस टू सम एक्सटेंट चलते रहते हैं. एनीवे लेट्स गो फॉर द क्वेश्चन आंसर प्लीज. एनीबॉडी लाइक्स टू स्पीक? जी
सफदर फ्रॉम शलमबाजार.
Okay, Assalamualaikum. First class, thank you, Dr. Jadun Saab, thank you, Tahir Alam, Janab Haq Minhas Saab. So I'm one of your younger colleague from the Shriram time. So I think as usual, you had a very good knowledgeable talk. And as always, we aim for increasing our knowledge. So just excuse me for a little bit longer question, Dr. Jadun asked not to be. So what I want to touch base on your recovery factor and reserves. So this is what my question related to that. And I want to ask about this, one of the unconventional reservoir Pakistan has, to my knowledge, is quite unique, very less example analogs to Pakistan, to other part of the world. And it's not surprisingly shale oil and shale gas. It is low matrix porosity fracture carbonates, which we have abundant in north, south, and center. Skaser, Lockhart, Dungan, Chilton, name few. So what my question is that in these carbonates where the porosity, metric porosity is in the very low range between 1 to 3 pu, I forgot about 5 pu, 6 pu, those could be some spikes, but generally less than 3 pu. Most of the production come through fractures, natural fractures, and most of the oil fields have been produced more than what the earlier estimates showed from the matrix porosity. If the well is really highly fractured, the fracture porosity by any mean does not go beyond 1 pu, although the permeability is huge. So question to you is, Arala, the challenge, what saturations we are talking about in these low matrix porosity, what reserves we are talking about, even we consider dual matrix porosity and fractures. By all means, storage capacity is very minimum. Most of the hydrocarbons are carried from somewhere where the matrix, more porous reservoir is connected to the fracture through the fractures. I believe I put it rightly. Thank you.
Absolutely. Let me try to rephrase your questions, Dr. Saab. That number one, you are saying that in many fields, the production has been for a long time, the fields have been producing, right?
Right.
So the production, the reserves are actually much more than initially anticipated. Of course, then it's basically a two-part question. Number one is that if we just look at the fractures and we assume that everything was there only in the fractures and there is no contribution from matrix, that assumption is not correct. So, of course, all the storage host is the matrix. So it is the matrix that has all the oil or gas, and it feeds into the fractures and the fractures flow. Of course, matrix is tight, and the charge from the matrix into the fractures is kind of slow. So that's why it takes so long. We produce the flush production, and then the matrix keeps on feeding those fractures. But my point is that we are depending on the natural fractures which are there. We can, with the technology of this unconventional, we can enhance those natural fractures. So we can go into those areas. The presence of those fractures tells us that there is the rock is quite brittle. It can frack easily. And when they did this slick water fracturing in US, which is basically very little proppant, all they do is they shake that reservoir. It creates those fractures. And if we can understand that those fractures are, that you'd know better than anyone else here, that if those fractures are the stress regime is near critical, those fractures will slightly move, and when they move slightly, they will create permeability within them without the addition of any proppant. So yes, if we can use this hydraulic fracturing technique in these tight reservoirs, naturally fractured reservoirs, we can achieve much more. But here in this case, again, let me tell you one thing, that if we go into this area which is highly fractured, we will not be able to do anything, because whatever we inject there will leak out. We have to go into the tighter zones. If we drill a well where the nearby well is producing, but that well does not encounter enough fracture, that is where we should go with hydraulic fracture. Let's have
I will just have a one short comment. Otherwise, I think we better do this discussion offline. Because other need to be talk. But one comment is that when it comes to tight reservoir, tight sands, they have certain porosity. When it comes to shale, they have certain storage capacity. But the permeability extreme is the issue. But when I talk about this natural clean carbonates, their storage capacity is absolutely minimum. By doing hydraulic fracture, you're not going to enhance the storage capacity. That will remain same. So the unconventional tight oil, tight shale is different, and our carbonate is different. But we can do separate discussion. I appreciate your response.
Just one little comment, Sabda Saab, that you will not increase the storage capacity. Storage capacity is the same, porosity is the same. But what is there is locked there. So the oil that is locked there, you want to provide some path to that oil to flow into the well. Let's have a discussion later on.
Okay. Thank you very much. Thank you.
So it's nice seeing you again.
Next, Tahir.
Thank you.
ये कोई और सवाल करना चाहते हैं?
मैं असगर सजाद बोल रहा हूँ। मैं सवाल तो नहीं है, क्योंकि ये तो बहुत हाईली टेक्निकल मिनहाज साहब बात कर रहे हैं। हमारी एजुकेशन तो बहुत पुरानी हो गई अब, तो वी कैन नॉट कमेंट ऑन दिस टेक्नोलॉजी एनी मोर। बट एनीवे, दिस वाज अ ब्यूटीफुल कंट्रीब्यूशन, मिस्टर मिनहाज. I just wanted to say, Mr. Tahir, that we have a team of 45 petroleum engineers and professionals, and they have a lot of courses which we can present to this forum. We have Mr. Minhas, who has already told me he has more than 10 courses he can present. We have Iqbal Sipra, he has artificial lifting courses. He has about 5-10 courses like that. Then we have Javed Mehtab Shah, he has a well-controlled courses. And then we have Dr. Salman Gauri, who is a petroeconomics specialist. He has a lot of courses. So we can take a lot of courses.
Sajad साहब, अगर ये courses की list आप हमें भेज देंगे ना, तो we will put this on our website here, और people will be able to know कि कौन-कौन से courses आप offer करते हैं. फिर आपको मिनाज साहब साथ हम coordination करके we can arrange courses in Pakistan physically भी, industry के लिए भी हम arrange कर सकते हैं, और through web भी कर सकते हैं इंशाल्लाह. ठीक है?
बिल्कुल. Mr. Minhas is the coordinator in Pakistan. He will do that definitely.
मिनाज साहब के साथ तो हमारे काफी पुराने रवाबत है, और भी इनको हम एक स्टिमुलेशन पे जो है कमर्शियल कोर्सेज हम बहुत जल्दी करेंगे इंशाल्लाह पाकिस्तान में, और पूरी इंडस्ट्री के लिए हम इंस्टीट्यूट में यहाँ पे इंशाल्लाह. ठीक है जी. रफी अजीज साहब क्वेश्चन करना चाहते हैं. रफी अजीज साहब, क्या हाल है आपके? ठीक है रफी अजीज?
आपकी पिक्चर नजर नहीं आ रही.
उनका नाम तो आया कि ही लाइक्स टू आस्क सम क्वेश्चन. चले कोई एनीबॉडी एल्स? कोई और कोई कमेंट्स? नथिंग. फिर हम क्लोज अप करें इसको.
अब डॉक्टर साहब
जी,
ये हक में नार साहब से फॉर माय कंजम्पशन, माय इग्नोरेंस, would he categorize the difference between the IOR and EOR?
जी बहुत आसानी से
इन्होंने बड़ा नीचे कर दिया कि जी 6% उससे होती है. लेकिन whatever he said about the water flooding, water injection and fracturing, तो ये समझ से मैं थोड़ा कंफ्यूज हूँ. मैंने कहा कि excuse me for my ignorance. मेरी
ये इसमें बड़ा वाज़ेह फर्क है कि अकमल साहब गो एट प्लीज, ये बहुत आसानी से बता देते।
देखें दिस ये सॉरी क्वेश्चन किसने पूछा है?
क्वेश्चन इनका ये है कि EOR और IOR में हाउ टू डिफरेंशिएट।
बिल्कुल क्वेश्चन पूछने वाले कौन है सर? नाम बोलिए।
रियाज खान साहब।
रियाज खान साहब सर, क्या हाल है आपके? ठीक है सर। देखें ये जो सारी है ना, ये पिक्चर जो है दैट इज बेसिकली शोइंग sort of difference between इसमें कुछ एलिमेंट्स मिसिंग है। तो up to this water injection everything is IOR. So when we do water injection, that is part of IOR. We do hydraulic fracturing, that's IOR. So in a way, in fact, what I will do is I'll go back to my this picture.
बेसिक डिफरेंशिएट कर दे कि EOR कहाँ पे अप्लाई करते हैं और IOR क्या होता है, जस्ट बेसिक इसमें एक फर्क है जो
IOR is basically improved oil recovery, so that includes also EOR. IOR is a big thing, big picture, that anything that you do to improve recovery is called improve oil recovery, IOR. That includes EOR. EOR is actually the part of IOR. Okay, so IOR is like the examples are hydraulic fracturing is IOR, stimulation, any other stimulation, horizontal wells, water flooding, these are all IOR. Whereas if you do sunny surfactant flooding, CO2, miscible flooding, these are examples of EOR.
मेरे ख्याल में अकमल साहब जो अगर रेजिडुअल ऑयल सैचुरेशन को जो रिड्यूस करती है केमिकल प्रोसेस से, दैट इज EOR, और जो आपकी एग्जिस्टिंग रिजर्व्स को इंप्रूव करती है वो प्रोबेबली IOR है। जिस तरह फ्रैक्चरिंग है, आप वेल ड्रिल करते हैं, डबल वेल ड्रिल।
Absolutely. Basically, if you are injecting any new type of fluid which does not exist in the reservoir already, such as CO2, polymer, that is termed as EOR.
EOR because that reduces the residual oil saturation को मजीद reduce करती है.
Exactly. So basically, it reduces the interfacial tension (IFT), and that allows that water to basically clean more oil.
जी बिल्कुल जी. Any other comments, please?
जनाब इसाक साकी साहब, अस्सलाम वालेकुम, क्या हाल है आपके? आपकी आवाज नहीं आ रही।
अनम्यूट करें अपने आप को।
आप अनम्यूट करें अपने आप को।
और ये किसने म्यूट कर दिया?
हाँ ठीक है, हो गया जी।
अब ठीक है।
हाँ, आवाज आ रही है जी? अब
आवाज तो आ रही है। आप कैमरे को थोड़ा सा एडजस्ट करें ना, पूरे आपकी जो ना माशाल्लाह अपने को फुल चेहरा आपको नजर आया
मेरी। अच्छा
बच्चे ने आवाज आ रही है, ठीक है।
ठीक, आवाज आ रही है तो काफी है। हाँ
जी जी, आवाज आ रही है।
मैं मुख्तसर कमेंट मेरा ये था कि सफदर साहब ने बाकी कमेंट तो कर दिया, प्रोबेबली मैं भी ऐसी ही बातें कहना चाहता था। एक चीज जो हमें कंसीडर करनी होगी वो हमारी टाइमिंग ऑफ स्ट्रक्चर फॉर्मेशन और माइग्रेशन, उसको कंसीडर करना होगा कि सैंड में तो ये नेचुरल है कि वो सारी सैंड ही इम्प्रेग्नेट हो जाती है, लेकिन अगर स्ट्रक्चर के बाद फ्रैक्चर्स के बाद फ्रैक्चरेशन के बाद हमारी माइग्रेशन हुई है, उस सूरत में मैट्रिक्स का जैसे हमारे कार्बोनेट रिजर्वायर्स हैं, तो मैट्रिक्स का कंट्रीब्यूशन इनमें हमारे रिजर्वायर में बड़ा मुश्किल नजर आता है। और ये छोटा सा कमेंट मैंने करना था, मेहरबानी।
ठीक है
जी। जदून साहब, दिस इज डॉक्टर गुलफाज, आई लाइक टू आस्क अ क्वेश्चन।
प्लीज।
First of all, it was a very interesting presentation. In a short time, he's been able to pass on so much of information. Well done, Minhas sahab. My question is, you actually identified a very important phase of reservoir development, that is reservoir characterization. Now, my question is that has the technology improved to an extent that by using highly focused and designed seismic before the development of reservoir, we can actually get to identify the heterogeneities. We can even try to get the reservoir fluids, mapping. Are those things possible using artificial intelligence, which will make reservoir development a much more scientific phenomena?
Okay. Well, thank you for your question, Dr. Well, one thing is that with the seismic, If we want to identify, of course, seismic traditionally used for structure identification, identify faults, etc. If we want to go to next level of fluid identification, people are using these days 4D seismic. In 4D seismic, they do, of course, seismic, 3D seismic, but at different times. So as the field is producing at different times when they do the seismic, rocks are the same, but the fluid has moved a little bit up and down, and that gives some kind of changes in the reflection, and from there you can identify the movement of fluid. So
my question was that if the technology has improved that we can identify heterogeneity and fluids, then we can do that focused seismic before development of reservoir and develop it very scientifically.
In a way, it has been yes, you have a different type of seismic which has really improved a lot. In offshore area, there is seabed seismic that is doing wonders. Then there is another technology, because seismic itself has kind of inherent limitation of physics. When you send a seismic wave, its high frequencies get basically absorbed in the upper layers. So what goes down actually is already the high frequencies that will give you high resolution already have gone. Now, there was a technique that has been there, and many companies are using it now more and more, which is tomography, where you have probably Safdar Saab can tell more about it. Basically, where you have, in fact, it's a next version of VSP. In VSP, you have a source at the surface, so you don't basically get two-way losses. Okay, it's only one-way losses. But now tomography has gone to the next level, where you have well-to-well seismic. In one well you have source, in the other well you have geophones. So that gives you much more high frequency seismic, and that will give you a better resolution, and you can probably identify minor features. This is one thing. Another thing that is being done is, while drilling those wells, because you have seen the big structures on seismic, you want to see the minor details within that, especially when you are drilling a well, horizontal well. You want to see, in fact, for example, if you are close to water contact or you are away from water contact, you want to keep the well at optimal location. These days, there are dielectric measurements that allow you to basically identify those heterogeneities, including fluid contacts within hundreds of meters. So those are, people are using that quite often these days. So but in 3D seismic, typically, you see, as I said, there is a limitation of physics, and you really can't change that.
Can I add one comment here?
Yes,
This is Akmal Sultan.
Thank you very much.
How are you?
I want to follow up with Dr. Gulfaraz. What he is saying is, and I have been engaged in last 20 years. I just finished my last assignment with ExxonMobil in Abu Dhabi, and I have been engaged in drilling almost 485 wells in one of the largest fields in the world. And let me tell you what's happened there. When I joined that company, they were producing 500,000 barrels, and they have been horizontalizing their wells in certain direction without knowing exactly, precisely mapping the fault directions, maximum which direction is the orientation of the fault is. And once I got involved in characterization, I'm catching up where Dr. Gulfaraz is getting there. Basically, once you have a well drilled, I would not go for blindly start drilling development wells with all kind of latest technologies available without knowing the fracture composition and their orientation and the direction of the faults. And once you establish that, particularly in carbonate, once we have established that after 3D and a very extensive 4D feasibility study, I ended up with, and believe me, working in 9 years with ExxonMobil's technology, we ended up with absolutely changing the orientation of the horizontal wells. And as of today, they are producing more than 800,000 barrels from 500,000. So it's a potential increase, and it's a contribution of understanding and precisely mapping the seismic data. So I backed up with Gulfaraz that in the industry, unfortunately in Pakistan, the things missing is we rush to after a small discovery for its development without understanding the composition and characterization of the reservoir. So faulting and fractures are extremely important, and we must concentrate and fully understand so that we orient our horizontal direction in a way which can enhance production. That's what my 20 years of carry.
Dr. Saab was just saying that, yes, you mean technology is available to guide you about fractures and fault configuration in the field. Okay.
Yeah, but I'm saying, what I'm saying is that seismic is one of the key role played in one of the fourth largest oil field, which has 64 barrel reserve, and it has no problem producing from any part of the field. But even then, we could not going beyond 500,000. But once we have put seismic into picture, and this is the case where 1,000 well been drilled, and you blindly hit the well and you are producing. What we have done, and I have many examples in which we have enhanced the production from 4,000 barrel a day to 7,000-8,000 barrels.
Yes, Akbar Saab, it's very good. Thank you very much for inputting very important information. So this means that if you properly design 3D seismic, you can define the fracture distribution in the field and fault configuration much better than simple 3D.
Absolutely.
Dr. Gulfaraz Saab, you are okay now?
Yes, my point is that after we have discovered a field, and before we make the field development plan, we need to carry out this, whatever we call 3D or focus 3D or 4D. We need to do that to characterize the reservoir and develop the field in a very, very productive manner. That was the comment, and thank you very much.
Absolutely.
That's very good. That's good. Thank you very much. Any other questions, please? Anybody likes to speak or any comments? For next 5 minutes, we are going to close, please. Anyway, I think this is wonderful. No more questions. Great contribution from Minhas Saab. Thank you very much for giving us a wonderful lectures and insight about the IOR. And I hope we will be able to introduce this good kind of technology in Pakistan for enhancement of production, which is really essentially required in these days. Pakistan is 70,000 barrel produce कर रहा है, और we need हमारा जो per day consumption है 4,50,000 है, तकरीबन about 400,000 barrels से above है. We are only producing 17-20% indigenous oil production, and similarly gas. So we need all these good technology to be applied in Pakistan. I hope our industrial leaders and company leaders should focus on this enhancement of production, improved oil recovery, so that we can minimize our import bill. Thank you very much, Minhas Saab, and all the participants from state and from other part of the world. Thank you very much for your participation.
If I can add just one thing, Dr. Saab, if there's anything like a kind of takeaway from this this discussion, is that we should really try to understand where we stand, where we are today. Are our recovery factors up to par? Are we performing very poor? Or why our recovery factors are low? So this is really the kind of question that we should put up to everybody in the industry. Why our recovery factors are so low? Okay, so and there is and we can start with this simple exercise, doing a benchmark.
वैसे just a final comment, क्योंकि मैं पाकिस्तान के मुख्तलिफ बहुत से फील्डों में कुछ काम किए हैं, जॉइंट वेंचर में. एक तो बहुत बड़ा जो इशू पाकिस्तान में, एक तो बहुत जैसे अभी अकबर साहब कह रहे थे, हमारी बड़ी स्मॉल डिस्कवरीज हैं और छोटे छोटे फॉल्ट ब्लॉक्स हैं. उनमें हमने सिर्फ एक वंडरफुल वाटर इंजेक्शन किया, जो हमने बड़ी मैक्सिमाइज रिकवरी. एफएम कसर हमारा फील्ड है जो तकरीबन 4800 प्रोड्यूस कर रहा था, उसकी एक्चुअल एक्वाफर उसके साथ नहीं था, तो रिड्यूस अप टू 2200 बैरल, और वाटर इंजेक्शन हुआ. इट वाज सो सक्सेसफुल. उस एक वेल ने 13 मिलियन बैरल प्रोड्यूस किया थ्रू वाटर फ्लडिंग के. तो वाटर फ्लडिंग इज वन ऑफ द मोस्ट इजीएस्ट थिंग वी कैन डू इट इन पाकिस्तान. सिर्फ उसमें जरा डिटेल स्टडी की एवेल्यूएशन की जरूरत है. एक तो हमारे छोटे छोटे ब्लॉक्स है और छोटी डिस्कवरीज है, स्पेस नहीं है जिसमें ईओआर या आईओआर IOR हो सकता है, लेकिन EOR पॉइंट ऑफ व्यू से मुश्किल है। इस तरह जो हमारे नॉर्थ के फील्ड है,
this is, I understand that, Dr. This is where horizontal and complex well technology will help. With one well, you can penetrate many fault blocks. So and you have so much control in the downhole and the well that you can produce every block independently.
और एक जो हमारे पटवार कोहाट बेसिन का इशू है, वो बहुत डीप रिजर्वायर है और हाईली स्ट्रेसफुल है, हाईली प्रेशर वाले हैं। उसमें ड्रिलिंग सेल्फ इज चैलेंज है, लेकिन यहाँ पे किया जा सकता है क्योंकि यहाँ रिजर्वायर के जगह मोर देन 5000 मीटर 4000 से लेकर 6000 मीटर तक जो है हमारे डीप रिजर्वायर है और नेचुरली फ्रैक्चर्ड है और फिर एक्वाफर अटैच है इनके साथ। तो जहाँ पे एक्वाफर की प्रेजेंस है वहाँ पे फिर ये सारी चीजों को जरा डिटेल एवल्यूशन करने के बाद करनी पड़ती है, लेकिन नेवरथलेस वी शुड ट्राई आवर बेस्ट टू ऑप्टिमाइज आवर रिकवरी। दैट इज द ओनली नीड ऑफ द डे।
Really, this is something that for recovery improvement, I really strongly suggest that we should kind of make a task force, reach out to the regulator, to the government, propose them. These are the kind of, to me, it is like a low-hanging fruits.
बिल्कुल
quick gains.
Anyway,
thank you.
Thank you very much for everybody जी, जो जितनी भी पार्टिसिपेशन हुई है, we are thankful to all the participants from state, from probably किसी और जगह से भी है और पाकिस्तान से भी है। हमारे सीनियर कोलीग्स भी हैं, रियाज खान साहब, डॉक्टर गुलफराज साहब, साकी साहब और रफी साहब और सबसे सीनियर मोस्ट सजाद साहब फ्रॉम ह्यूस्टन से। So that is we are lucky that we have seen so many good people around us। और हमारे साथ सबसे अच्छी बात है सब लोगों की दुआएं भी शामिल हैं। We cherish their inputs in every aspect of life. Thank you very much.
डॉक्टर साहब, सजाद बात कर रहा हूँ। सबसे अच्छी बात यह कि जैसे फजर का टाइम था, नमाज पढ़ के मैंने ये खोला तो बहुत मजा आया है। अल्लाह ताला इसको और भी हम इंशाल्लाह इसके अंदर कंट्रीब्यूट करेंगे।
आमीन। बहुत शुक्रिया जी, थैंक यू वेरी मच।
डॉक्टर मैं एक चीज ऐड करना चाहूंगा थोड़ी सी
जी।
ज़रा इसके जो हमारे पार्टिसिपेंट्स हैं, दे आर ऑल बेसिकली जियो साइंटिस्ट और बिलोंग टू अ प्रैक्टिकल अप्रोच, और वट एवर हकमिनाज साहब सेड वी कैन अंडरस्टैंड वेरी इजीली। द इशू इज दैट कि जहाँ की हम एग्जांपल्स दे रहे हैं, सऊदी अराम को दे आर रनिंग 150 रिग्स एट अ टाइम। सो जस्ट इमेजिन द वॉल्यूम ऑफ ऑपरेशन। भाई अकमल जो एडनॉक की बात कर रहे हैं, दुबई में है, उनके नंबर ऑफ वेल्स देखें, नंबर ऑफ रिग्स कितनी है। तो वहाँ तो शायद जितना ह्यूज वॉल्यूम है उसकी आउटपुट और वहाँ जो इन्वेस्टमेंट हो सकती है वहाँ तो कोई इशू नहीं है। हमारे यहाँ पाकिस्तान में जो सबसे बड़ा इशू है, टोटल नंबर ऑफ रिग्स ही पाकिस्तान की 15 से 20 से ऊपर जाती नहीं है, इसमें से 12 तो ODDC की हैं। सर हम तो प्रोडक्शन वेल नहीं कर सकते, तो हाउ वी कैन इंडक्शन वेल, वाटर इंजेक्टर वेल और स्टीम इंजेक्टर वेल। तो इसमें मेरा ख्याल, मैं जो कहना चाह रहा था कि एक हम सेशन जो है वो नॉन जियो साइंटिस्ट के लिए, जो टोटली जिनको हम कमर्शियलिटी दिखा सकें, वो भी होना चाहिए ताकि वो भी अंडरस्टैंड करें कि इसका आउटपुट क्या होगा।
एक हो सकता है, एक सेकंड बस, एक काम हो सकता है कि हम पाकिस्तान के टिपिकल फील्ड की हमारे पास डेटा है, तो वो हम एक दिन पाकिस्तान के डिफरेंट का वो सामने रख के हम आपकी कम्प्लेक्सिटी एक दिन हम उसको भी लेक्चर दे सकते हैं बहुत इजीली। आई कैन अरेंज एंड पीपल अराउंड अस, जितने लोग हैं वो कर सकते हैं कि पाकिस्तान की प्रॉब्लम का इशू पता चले हमें।
बिल्कुल ठीक है, अंडरस्टैंड। This will be wonderful if we can kind of some companies can share us their practices. That would be much better because that would be very very nice.
मैं वो कर सकते हैं, मैं I can do it with the permission of companies, and जो अवेलेबल डेटा है उसके बेसिस पे हम आपका 3 केसेस ले रहे थे, क्वाड पटवार और सेंट्रल पाकिस्तान और साउथ। तो देन इट्स वेरी इजी फॉर एवरीबॉडी टू अंडरस्टैंड कि हमारी कम्प्लेक्सिटी और हमारे इशू क्या है।
Absolutely, let's do that.
रफी अजीज साहब, आपका कोई मैसेज आता रहता है, आप बात करना चाहते हैं? रफी अजीज साहब एक सीनियर मोस्ट प्रोफेशनल है ह्यूस्टन में, मैं बार बार मैं कहता हूँ उनका मैसेज आता है लेकिन बात नहीं कर रहे।
रफी अजीज साहब को मैंने मैसेज किया है व्हाट्सएप पे भी, कोई जवाब नहीं आ रहा।
चले ठीक है जी, ओके जी, बहुत शुक्रिया जी, थैंक यू वेरी मच।
ऑलराइट, थैंक यू
थैंक यू वेरी मच, अप्रिशिएट दैट फॉर एवरीबॉडी।
बहुत शुक्रिया जी, थैंक यू जी, खुदा हाफिज।
ओके जी, अल्लाह हाफिज,
बाय बाय गाइस, थैंक्स फॉर योर टाइम।